Hello everyone, welcome back to our channel. So today we are there with the problem that is most oftenly asked in coding interviews, that is related with linked list, and also there on the lead code blind 75 SD sheet. So basically the name of the problem is remove nth node from the end of the list. Okay. So we have been given the head of a linked list. We need to remove the nth node from the end of the list, and we have to return its head, right? So we can see from the figure, this figure I captured it from the lead code. So basically this is the linked list 1, 2, 3, 4, 5. And here what they did is basically they removed the nth node, basically the node at which the data is 4. So basically this node is deleted, bit is basically removed, and the output node is basically 1, 2, 3, 5, right? So in the example we can see input is given as head is equals to 1, 2, 3, 4, 5 and n is equals to 2. So if we see n is equals to 2, so the output will be 1, 2, 3, 5. Okay. Since we can see the node is removed from the end of the list, so we have to count it from from backward. So we can see that the second last node is removed. So the output is 1, 2, 3, 5. In this we can say that input head is equals to 1 and n is equals to 1. So basically this node will be out from the linked list. So linked list will be empty this time. Now we have to see in the example 3 head is equals to 1, 2 and n is equals to 1. So if we count n is equals to 1 from the last, so 2 is the first, 2 is at the first node, so it will be removed and the output we will get as 1. If we wanted to see the think of a problem in much deep manner, so we have been given a singly linked list and we need to remove the nth node from the end. Please see this line. We have to remove the nth node from the end. So input I already told you all. So what we can do, basically the brute force approach to solve this question. First of all, it's very obvious. We need to traverse the linked list and the node at which it is given as 1, 2 or something like that. We need to remove the nth node from the end. So the steps are quite not so complex. It's easy. So we will count the total number of nodes in the linked list. Let's say SZ. Okay. And SZ represents the size of the linked list, the total number of nodes present in the linked list. Then after counting, what we need to do is basically we need to find the position to be deleted, right? That is SZ minus n plus 1 from the beginning. Okay. Afterwards, we need to traverse again and just we need to remove the node at this position first. So basically what we are doing, first of all, we are finding the position to be removed and afterwards we are removing the node. So we can think of a time complexity here. So for finding the position, the linked list we will traverse the complete linked list. So O of n, and again for removal, so that will also we will traverse through the linked list. So basically 2 times the for loop will run. So one pass for counting, another for deletion. So basically the time complexity for this approach will be O of 2n and the space complexity will be O of 1 because we are not using extra space. So my thinking is basically let's optimize this approach because we are having a better solution than this. Okay, so let's think of a better solution than this. So better solution in what way we have to think? We have to reduce the passes. Okay, here we are using 2 passes, so we need to reduce it to 1. So let's see how we can do it. So we will be thinking of a slide one pass. For one pass we will be using 2 pointer technique. 2 pointer technique is quite simple. We will use 2 pointers, fast and slow, to find the nth node from the end in one traversal, right? So our logic will be like very simple. It is similar to the tortoise hare approach, but not completely similar. We just need to see, like we need to move the first fast pointer in n steps ahead. Basically n is given in the input and we need to move both fast and slow pointer together until the fast reaches the end. Okay, and slow will now be just before the node to delete this time, right? So basically we will modify the slow, that is slow's next. We don't even need to delete it. Okay, we just need to point the slows next to skip the target node. Okay, so I will show you through the code as well. First of all, let's see the lead code solution. So basically this is the linked list declaration we have. Okay, so this is the function remove nth node from the end, and this is head, we are passing it in the function n. Okay, so for handling the edge cases, we need to create a dummy node basically for doing operations like deleting the head node. Okay, this is the basically edge case. So dummy we have created, and dummies next we are pointing to head. Now we are initiating two pointers that I already told you, fast and slow, and both are pointing to dummy, right? Now it's time to move fast ahead by n+1 steps, so that slow is just before the node to delete. Okay, and afterwards we need to, what we have to do at the same time, like we have to move both the pointers one step at a time until fast reaches the end. Okay, so after that, slow is now at the node just before the node to be deleted, or we can say to be removed. We don't need to delete it, I'm sorry, we need to remove. Okay, so slow is now at node just before the one we need to remove. So this time we are creating a new node like list node del node is equal to slows next, which will store the node to be deleted, right? So slows next is now pointing to slows next. That, so this line basically depicts like we wanted to skip the node to be removed, so we are pointing the node which is just previous to the node which is to be removed. We are making it point to the slows next and next to next. Okay, we are skipping the nth node from the end, and after that we need to delete the node basically in order to free the memory, as we already told you. Basically we have to find the location at which point at which node we need to remove. So after removing it, we need to make some free space, so we need to delete that node. Okay, after that we need to return the modified list, that is the dummies next will be the new head. We need to return the dummies next. Okay, so the this is first of all I would like to tell you like everything I discussed was happening in just one pass, like single pass through the list we are doing of n time complexity will be there, and space complexity is obvious like O of 1, because we use only pointers, no extra space. So I hope this solution is clear to everyone. If you like the video, please hit the like button and share it with other students as well. Thank you.